Hello guys, this is SHYSKY Tech. In this video, I will talk about this micro brushless DC water pressure pump. Among our series, this model DC50K-24160S model. As we can see, this is the pump body part, inlet and outlet. Both ports are with external diameter about 14 millimeters, not threaded. The pump itself is with rated voltage of 24 volts DC and with rated power consumption about 86 watts. The maximum static lift of this pump can reach about 16 meters, while the maximum horizontal flow rate of this pump can reach about 1,300 liters per hour. So, as we can see, this pump is with good output water pressure performance, while the water flow rate value is still considerably good. Okay. Then, coming from the pump body part, we will see the cable connection. This is the rectangle-shaped metal box. Actually, it is the control box part of the pump, or the whole pump. The control box part, we can see it as the brain part of the pump, because the main control and protect circuits actually integrated with it. When the installation, our pump body part can be suitable for submersible installation underwater, or be connected with both ports with external matching hose in the circulation or cooling system. While our control box part is recommended to be placed at somewhat dry and relatively lower temperature location. Okay, and here it is the power cord, DC head power cord. As to the polarity, inside positive, outside negative, DC 24 volts power. Okay, this is about this pump. And now I already ready this power supply. Adjusted the output voltage being 24 volts DC. Okay, I will use it to power our DC50K pump to see its performance, to see its water pumping scenario. Okay, first we can take a look at the pump's performance when it is in abnormal dry run scenario. Namely, it runs with dry run with air rather than with water. Of course, this is not allowed when in our normal applications. But here, we show this scenario as a display. Okay. DC head, female, and the power supply, DC head, male end. We plug them with one, the other. And now our pump runs. As we can see, our pump runs discontinuously rather than high-speed running all the time. This is the dry run protection design. Because this can reduce the rotation speed, the rotation frequency of this pump, and can reduce the physical friction, the heat generation in this abnormal scenario, can protect this pump in the system. But please try our best to avoid the dry run scenario, because this is always negative. We can take a look at the power consumption value, just 0.2 to several watts when in dry run abnormal scenario, right? As a water pump, of course, we test it, place it on the water. I get ready of this one bucket of water, and then now we place our pump on the water. Seconds delay exists when the pump changed from the abnormal dry run scenario to the normal water pumping scenario. We will see our pump runs normally with no noise at water pumping. We can feel it. In the meantime, let's inspect the electrical parameters. Okay. 80 volts in this context, and 24 volts DC power supply. The working current 3.3 amps. Let's go back to the pump. And then we change this pump from this normal water pumping scenario to abnormal dry run scenario again. As we can feel, the dry run protection is automatically triggered again. Yeah. We place the pump back into the normal water pumping again. Actually, seconds delay exists because of the detection. Actually, our pump hose, as we can see, placed on the water, or it can be connected with external hose when cooling system. Yeah, either will be fine. Just to make sure that our flow can actively and sufficiently power into inlet cavity of the pump. Yeah, this is demanding. Okay, this video is recorded here, and I thank you for your time. SHYSKY.